Hello, welcome to Dual Academy, where learning becomes much more easier. Today we'll be having an introductory course to Physics 1 to 3, which is titled Properties of Matter. And it's only proper that before we go into discussing the properties of matter, we discuss what matter is in itself. And what is matter? I want you to give me a view of what matter is in the comments section. But then matter is defined as anything that has mass and occupies space. I know before now you might have been defining matter as anything that has weight and occupies space, but that will not be so right because of the word weight in it. And whether a body feels its weight or not, whether a body is in space, out of space, or on net, whether it's weightless or not, a body still possesses its mass. So therefore we define matter as anything that has mass and occupies space. Now, basically everything we can see, everything we touch, we feel in our day-to-day life are made up of what? Matter. Even the air we can't see are made up of matter. And this matter doesn't just show up from nowhere. They are made of so many constituents. Let's discuss the constituent of what matter, and let's see how matter comes up to become the gigantic building and the mountains we see around, and even yourself. Now, matter comes from what? Summation or combination of what? So many molecules. Now, molecules itself are made up of what? Combination of what? Of atoms. So you need so many atoms or more than one atom to make molecules. An atom is made up of what? Electrons that revolve around the nucleus. So I have electrons revolving around the what? The nucleus. Now in the nucleus, which is the center of what? Of the atom, we have what called the proton and the what? Proton and the what? The neutrons. So these are the constants that make up matter. We have protons and neutrons coming together to make nucleus. We have electrons revolving around the nucleus, which is the perfect structure we have for an atom. The combination of this atom gives us what? Molecules and then matter. Now the idea I want to speak for me is that what? Matter is what? Is neutrally charged. Electrically, matter is electrically stable under normal circumstances. This is because the electron we have here what? They are negatively charged. Why the what? The protons are what? Positively charged. The neutrons themselves are what? Neutral. Therefore means that what? The nucleus is positively charged. The electrons are what? Negatively charged. Now they are equal charge, so they cancel each other, making matter what? Neutral. So electrically matter is what? Neutral. That's what I want to take from this diagram. So like I said before, basically everything we see around us are made up of matter. Now matter comes in different states and different forms. We have water, we have the mountains, we have yourself, we have your bed, your tables, and even the marker and the board I'm using, they all matter. But then they take different form. So what we want to discuss now is what? The states of matter. What are the different states that matter come in? Now we have 3 states of matter which I know you should know, and I believe you should know. If you don't know, then thank God you are at Dual Academy. Now the state of matter are what? We have solid, we have the liquid state of matter, and then we have what? Gases. These are the basic states of matter we have. Now solid, liquid, and what? Gas. Now they look so different. Now what makes a solid different from a liquid and a liquid different from a gas? Now the major factor that makes solid, liquid, and gas distinguishable are what? The intermolecular forces between the molecules. And let's discuss solids. Now, it's obvious that what? Solids are what? They are very compact and rigidly held together than what? Liquid and gas. And that's why you can have the stone, your chair, and your table not flowing while liquids float. Now, the intermolecular force that holds the molecules of what? Solids are very strong. Hence, the molecules of solid are held together, and then it gives them what? Definite shapes. It gives them definite shape. So solids have definite shape, and their molecules are held together in a regular pattern known as what? As crystals. And that's why, like I said, because of that force, they have a definite shape. Now, how about liquid? And the forces that bounce the molecules of liquid are what? They are weaker than that of the what? Of solid. So therefore, the molecules of liquid are freer to move around, and hence liquid can what? They can float. Now, liquid don't have a definite shape because they are not rigidly or strongly held together. What liquid does is to what? It takes the shape of what? Its container, its vessel. Now, gases on the other hand, they have very weak forces, very weak intermolecular forces between the molecules. Because they are so weak that they can even be neglected, and that's when we talk about things like ideal gas. So the forces that bound gases can be neglected. They can be neglected. So now, what does that imply for gas? It means that what? If I get a bottle of gas, a gas in a bottle, and it fills the bottle, if I empty that same gas in a room, an airtight room, the same gas will fill the room. It means because of their weak forces, they are free to move around. So the same quantity of gas that can fill the bottle, that same quantity of gas will fill a big room because what? They are free to move around. Alright, we already made mention of the different state of matter, solid, liquid, and gas. I want to talk about what? Change of state of matter. Change of state of matter. Now, in as much as matter come in their special forms as either solid, liquid, or gas, with the use of heat and temperature, we can transform one state of matter and change it to another state. So I want to discuss change of state. I want to discuss three special change of state of matter. We have what we call liquidification, or melting, we have evaporation, and lastly, to add, we have what we call sublimation. Now, what is liquidification or melting? And this has to do with what? Solid, changing the state from solid towards liquid. Now, we discussed earlier that the molecules of solid are they are tightly held by strong intermolecular force. Or with the addition of appropriate heat to a solid, it can change to liquid. And how does this happen? Now, once you begin to heat solid, the molecules that were held tightly by strong intermolecular forces become excited. So these molecules begin to jump around and hitting each other, they become excited and break the force holding them. Now, like making this illustration, let's say we have 10 little kids in a straight line in an assembly ground, and the kid at the back becomes excited and pushes the one in front of him. Now, willingly or unwillingly, that kid pushes the next pushes the next, and what we have is a stream of falling kids. And that's exactly how solid change states to liquid. One molecule at the base, having direct heat from the source, gets excited, hits the next hits the next, the rest hits the next, and before you know, the strong force which was holding them is broken down, and they lose their regular pattern as crystals and begin to float. So they are changed from solid to liquid. Now, what's the reverse state called? And that leads us to number 2, solidification or freezing. The process of turning liquid back to or straight to solid is called solidification or freezing. And I know we see that in our day-to-day life. You have the solid, let's say an ice, and melts to liquid. Now you take that same liquid to freezer and it turns back to ice, which is of course solid. So the process of changing a liquid to solid is called solidification, as the name implies, or freezing. Then what happens in the body is what is evaporation. Now if you begin to heat a liquid rather, now liquid continues to accumulate heat and temperature till it gets to a certain temperature known as its boiling point. For example, water has a boiling point of 100 degrees Celsius. It means if I keep boiling water, it will keep accumulating temperature till it gets to 100 degrees Celsius. Now beyond its boiling point, no liquid accumulates temperature anymore. What it does is that it begins to escape as gas. So the process of heating a liquid so that it gains enough temperature to begin to escape as gas is called evaporation. Now, lastly, we have sublimation. This has to do with the process whereby a solid changes directly to gas without the intermediate state. Now, conventionally, a solid should turn to liquid, and then it's being transformed to gas. When a solid transforms straight to the gaseous state, we call that sublimation. Now, what are the differences between evaporation and boiling? And there's a mix-up between evaporation and boiling if you don't get it clear. Now, boiling occurs at a certain special temperature for every liquid, known as its boiling point. But the evaporation can occur at all temperature. It can occur, although it is prominent after the boiling point. It means that when I begin to boil water, even before 100 degrees Celsius, it can start evaporating. When the evaporation becomes prominent after the boiling point. So boiling occurs at a fixed temperature, but the evaporation can occur at any temperature. Now note that what boiling occurs all over the liquid, all through the liquid. But then the evaporation only occurs at the surface of the liquid. So also, boiling causes an increase in the internal energy of a system. Whereas evaporation has to do with a change of state. So once the body begins to evaporate, it means it's changing state. Whereas what boiling does is increase the internal energy of a system. Alright, so if you enjoyed the video, please don't forget to give us a like. And if you've not subscribed, make sure you do so. Thanks for watching the video. Bye.